Good morning, people. So this is going to be a little talk more about this idea I have about restructuring the periodic table a little bit, or at least having a look at it. So let's start with here. We got the SPDF. Let me focus on that. Okay. So one of the things about the world and CP violation and all this kind of thing is that there's 360 degrees to the world we see. That's the way we usually think about it. But for some reason, electrons have this 720 degree thing, right? And this is why it takes 2 electrons to fill an orbital, right? In my model, it's like the Klein bottle, and you can look at some of my earlier videos, but the idea is that basically this electron is here now. I mean, both electrons are here now because they're filled, but there's a tucked inside, there's the anti of this. So each electron is 360 degrees in this world and 360 degrees in the antimatter world, so that they cancel out. And this is another electron, so that now they're satisfied, and there's 720 degrees of electron. And so there's the S. And the way the electrons work: 1, 2, element 1, 2, element 3, 4. And then there's an S, which is a 1, then a 1, and element 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? This is the way I'm just doing it nicely. But notice how it's like, there's 1 electron, then there's 1 electron, then there's 1 electron, then the electrons pair up, then the electrons pair up, and the electrons pair up. And I just think it's fascinating the way this simple geometry of sort of 1, then 1, 3, then we have a next S orbital, and again, electron and the counter electron, or the balance of the Dirac equation wave function thing, phase relationship, and then do sulfur, chlorine, argon, closing off the second 1, 3, S, SP, SP, and because of a thing in geometry, we now get this S, which is actually from the next set of orbitals. Let's just get an overview here for a second, for those familiar with chemistry and the way elements work. If not, it's really fascinating, so it's worth getting into, especially this interesting geometry that works out. So we get the S, and then we get the SP, and the SP, and this S actually belongs up here, though it happens first because of an energy thing that I think will be intriguing to look at. But I'm going to put that up here for a second. And then we end up getting let's tidy this up a bit. There we go. Right, S, P, D, and scandium, titanium, vanadium, chromium, all these crazy manganese at the end there. And then, because they start pairing up and leaving loose pairs, because these are all unpaired, but then iron has the pairing up, cobalt, because here's our strongly right there is our strongly ferromagnetic line right there, the iron, cobalt, nickel, boom, right? And then copper and zinc, no, in fact, they're like, because of their conductivity, they're like good field absorbers, sort of thing. Anyways, but it's like SPD. You notice this like 131, 13, 135. It would be 1357 on the 4. I just think that, these kinds of bizarre symmetries and geometries never mean nothing. They never mean nothing. They're usually indicative of something. Anyways, that's all. Just an overlook at that, and I just wanted to have another look at that.